Hi everyone. In today's video we're going to be talking about the chain rule. So there's really two parts to this. The first is to understand when we need to use the chain rule to take a derivative of a function. And then the second is learning how we use the chain rule. So I will be using a lot of colors to hopefully make things a little more clear. And so if you want to get some colors, I would recommend that you do that. So the chain rule really comes into play when we're finding the derivative of a function, which is actually the composition of two functions. So for example, if I wanted to take the derivative, so let's say I want to take the derivative with respect to x of, let's say I have a function that's a composition, so it's f of g of x. Okay, so we're taking the derivative of that composition of f of g of x. So for example, let's just take a quick little example. Let's look at the function 2x plus 3 quantity squared. So we could say our function f of x is x squared. So kind of that outer function, and our inner function g of x is the inside, or 2x plus 3. So if I were going to take the composition f of g of x, we know that means wherever I have x in my function f, I'm going to replace it with g of x. So that would, in this case, turn my composition would be 2x plus 3 quantity squared. So that's the kind of function we're talking about here. So if I want to take the derivative of my composition, here's what it's going to look like. We're going to take the derivative of our outer function first. So we're going to take f prime, and our inner function is going to stay the same. So f prime of g of x, and then we're going to multiply it by the derivative of our inside function. So to put that in words here, right, we're going to take the derivative of the outside function, and then we take the derivative of the inside function. So that's the basic rule for how this works, and we're just going to do a lot of examples today to make sure we know in practice what that really means. So here's where I'm going to use a lot of color to help us identify what's the outside function and what's the inside function for each problem. So here's where our colors again are going to come in handy. So I'm going to switch to blue and orange just because they're a little more different, so make sure that difference comes out in the video. So the first thing I'm going to do for number one, I'm going to rewrite f of x using some color here. So my outside function is going to be all of this to the fourth power. And my inside function is going to be x squared plus 3x. So when we go to differentiate, find f prime of x, the first thing I'm going to deal with is my blue here. I'm going to focus that to make sure, so we can get a little more clear. Okay, so the first thing we're going to deal with is the blue. So this is just going to be our basic power rule. So I'm going to treat this just like we did before. I'm going to bring down my exponent, and then I'm going to decrease my exponent by 1. Now the key here is when I do that, all of my inside stuff, kind of the guts there, are going to stay the same from this first part. So all I really focused on was the power rule for that first piece. Now I'm going to take the derivative of the inside. So now I'm going to differentiate that, and I get 2x plus 3. Maybe we'll ditch the orange here. I'm not sure how well that's coming out in the video. So now to simplify this, I'm just going to do some really basic simplification here, and I'm going to distribute this 4 to this factor here. So I have 8x plus 12, and I'm just going to leave this factor as it is, times x squared plus 3x cubed. And that would be our derivative. So that's a basic example of how this chain rule works. Okay, so I'm going to do the same thing here. I'm going to rewrite this first using colors. So now in my second example, my outside function is my cosine. So I'm going to make that in blue. I'm going to go back to the green here. My inside is x squared. So now that we've identified the outside and inside, we can go ahead and differentiate. So we said our outside function is cosine, and hopefully we've all memorized those trig derivatives. I know the derivative of cosine is the opposite of sine. And remember, my guts right now, the inside, are going to stay the same, so that's going to stay x squared. And now for my next step, I'm going to differentiate the inside function, so I'm going to multiply that by 2x. And so now I'm just going to do a little rearranging. I'm going to bring my negative 2x out front times the sine of x squared. And that would be the derivative using the chain rule. Okay, so again, we're just going to do lots of examples today so we are all clear on identifying that inside and outside function, because once we do that, then it's pretty straightforward finding the derivative. Okay, so again, in number 3, same type of problem as number 2. Again, my outside function is cosine, and my inside function is t squared plus 1. Notice I just put that equal to. I haven't found a derivative yet. I'm still just rewriting my original function. So now in the next step is where I use my derivative notation, f prime of t. And again, first I differentiate the outside function, which is cosine, and I get the opposite of sine. My insides stay the same, t squared plus 1, and then I multiply by the derivative of my inside, which is just 2t. So again, just a little rewriting here. Negative 2t times the sine of t squared plus 1 is our derivative. Okay, so number 4, again, this is really more practice as long as hopefully we all have those trig derivatives down. That's really probably the only maybe tricky part here. Again, my outside is tangent, and my inside is 2x minus 3. So when I differentiate, I take the derivative of tangent, which is secant, oops, I should do this in blue, secant squared. My insides stay the same. And then I multiply by the derivative of my inside function, which is just 2. So my derivative becomes 2 times the secant squared of 2x minus 3. Okay, so for number 5, outside function is secant, and my inside is x squared minus 3x. So here we have to be a little bit careful when we differentiate. We know that the derivative of secant is secant x tangent x. So now I have secant and I have tangent, and we want to make sure our insides stay the same for both of those factors. So the derivative of secant of x squared minus 3x is secant x squared minus 3x times tangent of x squared minus 3x times the derivative of my inside, which is 2x minus 3. And really with that one, there's not much to do, so we can just leave that answer exactly as it is. Okay, now for number 6, the first thing I'm going to do is actually rewrite this problem. And I'm going to rewrite it as 4x squared plus 5 to the 1/2 power. So now this is similar to our very first example. It's just that I have a rational exponent. I'm still going to use the power rule for my outside function. So my outside is all of this to the 1/2, and I'll be using my power rule there. My inside is 4x squared plus 5. So now when I go to differentiate, power rule is first, so I have 1/2, sorry, lost my colors there, 1/2 times everything on the inside to the negative 1/2 power. My inside is going to stay the same, 4x squared plus 5, and then I'm going to multiply by the derivative of my inside, which in this case is 8x. So now this one I am going to simplify. My 8x is going to stay on top. I have a 2 on the bottom, and then I'm going to move this negative exponent down. So it becomes positive, so I have 4x squared plus 5 to the 1/2 power. And then I'm going to take one more step. I can simplify 8 over 2 is just going to give me 4. So I have 4x all over the square root of 4x squared plus 5, and that's my derivative. So those are some pretty basic chain rule problems. There's just one other type that we want to look into for today. So we'll flip to the next page. Okay, and so we want to look at functions that are really powers of trig functions. Okay, and so even though it might not first look like it, taking the derivative of f of x equals sine squared of x is going to require us to use the chain rule. Okay, and here's why. If I have f of x equals sine squared of x, right, what that really is sine of x squared, the quantity sine x squared. So now if it's rewritten this way, it's really easy to see that our outer function is x squared, and our inside is sine of x. So now when we go to differentiate, outside is our power rule. So we have 2 times the sine of x. And when I reduce my power by 1, I just have to the first power. And then I'm going to multiply by the derivative of my inside, which is going to be cosine of x. So our derivative just becomes 2 sine of x cosine of x. So we just need to be careful when we have any powers of these trig functions to make sure we're handling them using the chain rule. So these are all just examples of those types of problems. So again, we're keeping in mind that tangent squared of x is just the tangent of x squared. So our outer function is our squared function. Our inside function is tangent of x. So in order to differentiate, we're going to take our outside, bring that exponent down to the front, subtract 1 from our exponent. Our inside stays the same, and then we differentiate what's inside, which becomes secant squared of x. And so we're just going to leave this as 2 times the tangent of x times secant squared of x, and that's our derivative. Okay, we'll go quickly through the next one. Again, in this case, what we really have is cosine of x squared. So our cosine of x is our inside. So in order to differentiate, again, it's our power rule. So So we take 2 times our original inside, which is cosine of x, and then multiply it by the derivative of cosine of x, which is the opposite of sine of x. So now I'm just going to simplify by bringing that negative out front, and my derivative is negative 2 cosine of x times the sine of x. All right, our next one is secant squared of x. Again, that is the secant of x, quantity squared. Outside is power rule. Inside is secant of x. So to differentiate here, we're going to have 2 times our inside function, which is secant of x. And then we're going to multiply by the derivative of secant of x, which gives us secant of x tan x. So I'm going to multiply my 2 factors here. I have 2 secant of x factors, so we get 2 times secant squared of x, if I combine those factors, times the tangent of x. Okay, and last but not least, now we're just going to do an example with cosecant of x quantity squared. And again, these problems are really all the same. It's really just testing if you know the derivatives of your trig functions. So hopefully at this point, you should be doing this kind of by memorization. We shouldn't be having to flip back and look at these derivatives each time we do a problem. So now I have 2 times my function cosecant of x, and then I multiply by the derivative of cosecant of x, which is the opposite cosecant of x, cotangent of x. And again, just a little bit of simplification gives me negative 2 cosecant squared of x times cotangent of x. So these types of problems are kind of our basic chain rule problems. As we go on with this, we'll be combining product rule and quotient rule with our chain rule, and then ultimately we'll be looking at problems where we have to apply the chain rule more than once. All right, and tomorrow, as always, we'll get work with practicing a lot of these types of problems. The end.